Hello guys, welcome back. In the previous video we were talking about X macro and some benefits, and in this video I want to show you another use case of X macro and its benefits. What I'm doing here, I'm developed some parameter peripheral drivers, and I realized that I have to duplicate a lot of code, so I think about X macro and some way to improve this. Let's get started. Here is a normal approach, right? When we develop any peripheral, we have to define a lot of macros like helper function also to manipulate. Like for example, in this case, I developed some GPIO and I have to define a lot of macro for each GPIO port to get the address based from the ASB1 bus. Another thing like here, I have to define duplicate code for to get the register for GPIO port corresponding, and I have to do the same thing to enable clock here. Not only this, I have, for example, here is only the GPIO, but in future maybe we have to develop more and more peripheral like timer or US or SPI, and we also have to duplicate all of this code, and it takes a lot of code and very easy to make mistake. For example, you wrong some bit or you using the wrong bus or similar thing. So we try to use X macro approach. In here I only define only one table for all peripherals and goodbye duplicating code. Let's see in the real code I'm coding here. I haven't finished yet, but in here I just drag the table like this. You can see this table includes 4 columns. The first is a peripheral length, and the second is the bus is nyon. The third is address offset from the bus, and the leg is corresponding register structure in C. And finally, I have defined the RCC code for like enables clock or reset peripheral and enables low power bit mode, for example. And here I can I do the same thing for all the CPIO and US here you can see. And for something special like RCC, it doesn't have the clock itself. I define another macro for its no RCC. It do the same thing for external interrupt here. Currently, I only develop the US and GPIO, so my table is just look like this. And let's see what I'm doing below here. Here is structure for each kind of peripheral, GPIO and US RCC here. You don't have to focus on it. And the thing start from here. First thing I do is generate the function to get the base address of the peripheral. I get it from base from bus. Here you can see parameter and the offset also. So what is actually look like in the real code? That's what is generated like here. I will show you. You can see the name is replaced to the function name here, and the bus replaced to the macro here. So I already have some real function like this. For example, in case of GPIOA, it's actually like and with the bus, you can see the bus is replaced to the macro bus base address, and see the GPIO based on the ASB1 bus, right? So we have the corresponding the bus base address here. And for the offset is a third parameter here, for example. So the function will look like this. So we don't have to define every function for each peripheral anymore. Only if you want to add more peripheral, just add to the table, and we already have the function. Let me try to clone this. Here, for example, I try to clone something like guest. Here you can see the Visual Studio automatically detects this function. Yes, and I try to build. Oh, sorry, I haven't included the chain yet. Oh, maybe we will do this in another video. So in this video, I just want to show you how can I improve our code, and not only to get the address. We do the same thing for another thing like get the register, right? So I also have another function for get register. Here, let's remove this. Yes, we also have this function. You can see it returns a GPIO underscore T here. What I'm doing here is just I make some pattern for this, and you remember the false parameter is a register type here, right? And we display with this GPIO underscore rec underscore T. And for the enable clock and reset, I do the same thing. You can see. And remove this. We do the same thing to enable clock here, but something quite more complex because some peripheral doesn't require RCC because like RCC itself don't need clock to enable, right? And something like interrupt, external interrupt. So in this code, I also generate function to enable the clock. Like this. Enable. Yes, we have this, so we never have to duplicate ourselves. Okay. And finally, I do the same thing for reset peripherals. You can check it here. Do the same thing with just change the name and replace with another. But here with another register, it's actually like a guess. You can see this here, this chart for RCC chart. RCC chart here, you can see we have the corresponding register, right? So I just replace the bus name in here. Back. You can see we just replace the bus name in here with enable back to this. So I do the same thing for every peripheral. So the next time I want to add a new peripheral, I don't have to replicate a lot of code like I just showed in the previous. For example, I want to add more peripheral like timer. In this case, I just do. Let's say I want to add a timer 1 here, and let's check the data sheet. First thing we need to do is just check what the bus is nice on and what is the base address. Let's check timer 1 first. Here you can see timer 1 based on AP2 bus. And what I do here is already AP2. And the base address would be 00, right? It's the first. So let's check here is 00. And I make another struct for timer like this. Timer. And for the RCC this map, we need to check the RCC here. What bit to enable the timer 1 and open the resistor. It lies on the APB bus, right? Here you can see the timer 1 also is the first bit. So I will fill 0 here. Maybe it's the same thing for another, I think. We have 3 RCC bit map here for recess bits, enable clock bits, and enable clock low power mode bit. So it's done. And for everything more detail, we have to define more like in GPIO case, I have to define more like API for specific peripheral, right? So in here you have to define your code to more specific like timer elite or something. But for something general, we can do everything in the same table and don't have to replicate ourselves. So it is easy, right? That's all for this video. I just want to share you another use case of X macro. Actually, in the real code, you can apply it to a lot of things related to like a database, working with SQLite or something similar. If you want like more example about the X macro and how I apply it to my project, and if you want, you care more about how I finish the parameter drivers for all the peripherals, just comment in the below section. I will check. Okay, so thank you for watching me. I hope you learned something. Bye bye.